Welcome to Building the Future, hosted by Kevin Horick. With millions of listeners a month, Building the Future has quickly become one of the fastest rising programs, with a focus on interviewing startups, entrepreneurs, investors, CEOs, and more. The radio and TV show airs in 15 markets across the globe, including Silicon Valley. For full showtimes, past episodes, or to sponsor the show, please visit buildingthefutureshow.com.
Welcome back to the show. Today we have Hannan Parvizian. He's the co-founder and CEO of Volansi. Hannan, welcome to the show.
Thanks for having me, Kevin.
Yeah, I'm excited to have you on the show. I think what you guys are doing at Volansi is actually very innovative and cool, but maybe before we get into all that, let's get to know you a little bit better and start off with where you grew up.
Yeah, absolutely. I was born in Isfahan, Iran. I went to primary school actually in the UK, in London. Went back to middle school in Iran, and last years of high school and university in Munich, Germany.
Oh, cool.
And then moved to the US, worked in the consulting industry with the federal customers and commercial customers, ultimately moved out to the Bay Area, got hired by Tesla, and the rest is history.
Very cool. So let's step back for a second. You went to university. What did you take and why?
I studied mechanical engineering at the Technical University of Munich. Background being that I wanted to study a discipline that would allow me to do a range of things after school, and engineering made a lot of sense because you can become a really good engineer. You could go and apply your engineering skills or analytical skills to business. Or you could, start a company. So engineering, in that sense, made a lot of sense to me as a discipline to take, to have the foundations and the basic skills that you would need in a business career or in a future career in general. And mechanical engineering specifically, I was influenced by my dad, who's also a professor in mechanical engineering, and so that was
very cool.
Kind of the background there.
Okay, so you get hired on at Tesla. Walk us through your journey up until founding the company.
Yeah, so I was hired by Tesla to do operations analysis. So what that means is I was looking at different data sets from across the company, service, sales, manufacturing, and trying to figure out where we can gain operational efficiencies or where we're inefficient and how we can improve that. And that was across different aspects, whether it was customer satisfaction, whether it was manufacturing, whether it was service or sales. And one of the last projects I worked on at Tesla before I was about to leave to actually go to business school was to look at logistics and getting supplies and parts out to service centers and delays that we had on the manufacturing and assembly line. And one day, as I was taking BART, which is the local train here in the Bay Area, to Fremont from San Francisco, I stumbled on the idea of using drones or unmanned aerial vehicles to enable faster shipments of these parts and supplies that we needed to ship out at Tesla in order to save downtime costs and help with customer satisfaction. And I am not a drone expert, or I didn't know anything about drones other than what I would just read through the news. So I started hanging out at Stanford at their UAV club, or Unmanned Aerial Vehicle Club, and started to meet with different engineers and understand really what the limitations of the industry and the technology were. And that's where through Stanford I met with my co-founder Wesley, and that's where we ultimately hired our first engineer from that Stanford UAV club. And based on that understanding, decided to start a company and start developing the technology that would make it viable for us to service enterprise customers like Tesla.
Interesting. Okay, so what made you decide to actually start the company? And how did you guys start it? Did you self-fund? Did you raise some money? Walk us through that.
Yeah, so the reason we decided to start the company is that based on what I had seen at Tesla and some of the market analysis that we had done, we realized this is a big problem that's not just limited to Tesla. Getting spare parts and urgent supplies out for any ongoing sustained operations, whether it's manufacturing or whether it's mining or whether it's any type of operations, if you don't have the supplies and parts that you need, and if your machines are down or if your operations is down, that costs you a lot of money. And it was kind of neglected because I'm not sure everyone, including ourselves, was familiar with how big this problem is in the enterprise space. And the way typically it was solved was either you were a really large company like an Intel and you had jets on a runway waiting to ship parts when needed, or if you're a middle-sized enterprise or smaller one, you would use a combination of express shipments, and the fastest method would be either someone hand carrying your part in a truck, or if it's a longer distance, you would use a service called Next Flight Out. So basically you would have someone come to your warehouse or to your site, pick up a part, take it to the nearest airport, put it in the next commercial flight to another airport, then have another truck pick it up there and then take it to the final destination. And all of this stuff takes a lot of time and there's a lot of money lost. And also these shipments are not cheap. So there's a lot of money spent on them too. And this seemed very inefficient to us, and drone technology made a lot of sense. That being said, we realized that we had to develop certain components of the technology and flesh them out even more to make it viable for businesses and for this application. And so after doing about 6 months of market studies and research, we kind of narrowed it down to 3 main technology components that were required to make this business viable. The first one being vertical takeoff and landing, or VTOL, to eliminate the need for infrastructure. Basically, we can go to our customers and say, I need to build a runway in your backyard to provide the service to you. Second was autonomy, because again, we couldn't have a fleet of hundreds of thousands of pilots operating these vehicles, because again, there's a limit on that side. And the third one was combining different propulsion systems to be able to carry different payloads and go over longer ranges. And that was kind of where we, based on that, realized, okay, what technology components were needed, and came up with our first concepts of the vehicle. And our first couple of months, even into the first year, we were self-funded. I basically sold any equity or shares I had at Tesla, and funded the company for a while. And then ultimately we got into accelerator programs like Alchemist, Y Combinator, and funded a company for that.
Very cool. Okay, so walk us through getting the actual first version kind of prototype done, and then let's dive a little bit deeper into the different verticals that Volansi actually plays in, because I think that's the thing that I found the most interesting about what you guys are doing is you guys do some really cool stuff in a bunch of different verticals.
Absolutely, yeah. So the first proof of concept delivery mission that we did with our first MVP, if you will, was back in 2017 once we launched out of Y Combinator. And that was for a customer in the high-tech industry, specifically in the semiconductor business, where again, the downtime cost is extremely high if one of the semiconductor fabs is down. And we delivered a spare part out of one of their warehouses over 100 miles in a round-trip mission, demonstrating that the technology was viable and we could deliver parts and supplies over a very long distance. And that was here in the US and near Austin, Texas. And that was a record-breaking mission in itself, because not only did we transport a part for an enterprise customer and prove the use case for ourselves, but also from a regulatory perspective, we had demonstrated a very long flight within the boundaries of what FAA allowed at that time. And so from that proof of concept, we got a lot of interest and traction from other customers, both in the high-tech industry, but also customers in other verticals like mining, oil and gas, and ultimately customers in the medical industry. And in 2018, we started working with Merck, who's been a longtime customer and partner of ours, in delivering cold chain supplies such as vaccines and other medical supplies, first intended to use for primarily disaster relief efforts, and ultimately now we're using it recurrently in the site that we have in Wilson, North Carolina. And we also then got interest from customers in the federal industry or in the government space that needed to deliver critical supplies and parts, especially in this case, they were interested in medical supply deliveries from shore to ship and vice versa, to help save a soldier's life on a battleship or on a ship in general. And we started working with military customers, specifically the U.S. Navy. And since then, we've grown the business to continue to really focus on those application and those customer verticals. We're excited to see how we can grow this business and help different customers with different use cases and applications over time.
Very cool. So just for some perspective,
how
much time does it save a company from, putting something on a traditional aircraft or private jet to get something to somewhere, or driving something? Like, how much faster is it by using one of your drones and kind of what you guys are doing compared to the traditional methods?
Yeah, I think it's not only just how much faster is the one vehicle versus the other. It's actually how different is the entire supply chain end to end.
Okay.
So, for example, if you currently want to ship something from, say, San Francisco to LA, which is about a 400-mile trip, and where you could argue you have a flight between San Francisco and LA probably every 10 minutes or 15 minutes from either San Francisco Airport or Oakland or San Jose, one of the airports here in the Bay Area.
Okay.
So it's a very frequent route, and you could also drive it in 4 to 5 hours if you wanted to. Now, in an enterprise use case, if you place an order right now at 11:18 a.m. Pacific time, which we're at on a Wednesday, the soonest option they will give you is probably 9 hours away from now, even if that's possible for them to deliver it today. Most likely tomorrow, first thing in the morning, is the best option you will get. If you go with a next flight out option, like with a UPS or a FedEx or one of the other third-party logistics providers. So in that context, if a drone is flying or one of our vehicles is flying, say, 60 miles per hour, which is not fast, still you're getting it there sooner than your best options that you currently have on the market. And the reason is because we can take off and land literally from your doorstep, from the top of your warehouse or in your parking garage, and land on the other side. We don't have kind of a multimodal logistics or combining of different legs of shipments just to get something there. And the vehicle is available at your disposal on demand. You're seeing at least a 5 to 6x improvement, even on a very high traffic route like San Francisco to LA. Now, with most of our customers, we're not talking about delivering stuff from San Francisco to LA. We're normally delivering to customers in industrial areas or in rural areas where you don't have this type of infrastructure and you don't have this type of traffic. So the improvements there are even more significant. And for example, we do operations in Western Africa and deliver supplies and parts for customers in the mining industry. And given the road conditions there and the lack of infrastructure, a simple trip that they need 2.5 hours to drive a truck from one point to the other, we can fly in less than 30 minutes. So there's a 6x improvement just on one leg of the trip. And on a round trip basis, you're getting a 5 or 6x improvement on one leg of the trip. On a round trip basis, you're getting a 10x improvement. So that's where I see the power of this technology, is that you don't need infrastructure. You can take off on demand, you can land on demand, and you can go point to point. And that's really a game changer and disruptor for this supply chain industry.
No, it's very cool. And so I get it's tricky when it's audio only to explain how it flies, but and correct me if I'm wrong, is it kind of like it lifts up like a drone and then kind of flies like an airplane, or how does that work?
Yeah, it kind of lifts like a helicopter, so vertical takeoff and vertical
Okay.
landing, and then it flies like a normal airplane, fixed wing. So it's a combination of the best of both technologies. Because if you just fly on a multi-copter basis, like a helicopter, if you will, all the time, then you require a lot of energy, and you can't cover long distance. So once you're talking about cruising, the most optimal means of flying is to have a fixed wing structure, basically like wings, and that's why you combine a regularly shaped aircraft or winged aircraft with a multi-copter structure on top of it, and that way you get the best of both worlds. So you can take off and land wherever you need to, and then you can be very optimized for cruise flight. So the way we take off, just to kind of describe it, is we take off from a flat surface, any surface, there's no infrastructure required. And then starting at about 150 feet to 250 feet, we start transitioning to forward flight. So that means a pusher motor or pusher engine kicks in and starts propelling the aircraft through the air like a normal fixed wing aircraft. And at some point, the multicopter shuts off, and then it's just flying and cruising like a normal plane. Once it reaches its destination, the multicopter starts to spin up again, slows down the aircraft because you're turning off the pusher motor or engine, and then it lands again vertically on the spot. So you're kind of combining two modes of flight, vertical flight and then normal fixed wing cruise flight.
Very cool. And then how does it work from a fuel perspective? Is it do you put gas in the thing? Do you just charge it up, or walk us through that?
Yeah, so the vertical system is electric powered, so it's powered by batteries,
Okay.
like lithium polymer batteries or other types of batteries that you could use. And then the cruise flight could be powered by batteries, so it could be electric, or could be powered by a gas powered engine, or a diesel powered engine, or other type of engine, if you will. So there's also the combination that we have on our electric 10 series, where the cruise flight is powered by an electric motor. So both of those are possible. And the difference is that you have what we call a separate lift thrust design. So your vertical system is independent of your forward flight system, and that allows for redundancy, and also that allows you to design a better combination of vertical lift system and a forward pusher system.
Got you. And then what's the rough range? It probably depends on which combination I pick, but do you want to give us kind of a range of these things?
Yeah, so our smallest platform, and when I say small, it's about 55 pounds gross takeoff weight, has about a 9-foot wingspan. It's our 10 series, which has a 10-pound payload capacity. In an electric mode, it has about a 50-mile range, and then it goes up from there. So our larger platforms and also our hybrid versions of the 10 series and other vehicles have payloads and ranges starting at 10 pounds and 50 miles, going all the way up to 1,000 miles, or in this case, right now we have our 20 series in the market, which is a 20-pound payload aircraft.
Got you. Okay. And then can I watch the thing fly, or does it plot it on a map, or how do I know where it's at, or whether it's reached its destination or not?
Yeah, that's a good question. So the flight, as I mentioned earlier, is autonomous. So autonomy is one of our key enablers. But that being said, you can definitely monitor the flight as long as you maintain communications with the vehicle, which we do over different command and control links or communication links. So it could be connected to the vehicle over radio. You could be connected to the vehicle over cellular network or over satellite network, depending on where in the world you're at and what kind of communications infrastructure you have. but if you're not connected to the vehicle, it will still fly, it will still do its mission. It's really the connection is there for you to be able to monitor the mission and intervene if you needed to.
Got you. Okay. And so when you say intervene, is that sometimes like related to weather conditions, or what does that mean?
Yeah, it could be a combination of things. It could be that you're flying through an area where you need to change course. Maybe you're flying next to an airport, or maybe you're flying next to a road, or maybe some a safety event happens and you need to take over the aircraft. So basically, you want to have communication with the vehicle in case those interventions are required. And part of it is also that you want to, part of it is driven by regulations and safety requirements. So again, the vehicle could do a lot of these things autonomously by itself, but it's good to have a human in the loop to help with that and also help with the safety case.
Got you. No, that makes sense. So do you have to pick certain flight paths based on regulations, or is it kind of just like get there the quickest way, safest way possible?
No, you certainly have to work with the regulators to make sure that you pick a safe route. So the way we kind of think about designing our flight routes, and our business model is to really fly fixed delivery routes for enterprise customers. And the way we think about it is do a lot of preemptive risk mitigation. So what I mean by that is we survey the route, make sure we know of all the obstacles. Not always are you getting the best data from maps and data that you have publicly available. So you have to do your own surveys, understand the obstacles, navigate through different airspace challenges that you might have. For example, if you're flying for a congested airspace or near an international airport or near a highway or a city or whatever it is, those are things that we preemptively mitigate by designing a route that's very safe. And we run that by regulators and get their blessing on that. And then we start flying that route back and forth.
Got you. So do you have to like tell any airports around that I'm going to be flying this medication or this vaccine here and there? Or like how much communication do you have to have with other flying airplanes and aircraft?
Yeah, that's a good point. I mean, depending on where you're at, yes, you do. So in some cases, we do fly near airports, so we call into air traffic control, let them know that we're flying, and give them a heads up. In some cases, the vehicle has a transponder on board, so it's squawking its position so that other vehicles or other aircraft in the area know where we're at and of our surroundings. And in some cases where there's really no air traffic out there, you may be able to not communicate with anyone, but for safety reasons, we always both communicate with the nearest airports, if there are any, and also with nearby aviators.
Got you. So I know you've given a few really good, useful examples, but is there any other examples of how companies or people have used your technology?
Yeah, so again, it's really about where the customer sees the need and the return on investment for this type of technology. So we're a company that's really focused on solving our customers' problems, or not necessarily dogmatic about the technology. So we try to design our technologies to really primarily serve the customer. And the use cases that we just talked about, and I'll highlight again, is on the medical side, it's about delivering life-saving supplies, either to someone who needs a medication or a vaccine urgently, or to someone who's stranded after a disaster and needs relief. On the enterprise side, it's really about saving on downtime costs and making sure that you can maintain uptime as much as possible in any sort of ongoing operations, whether you're an automotive manufacturing assembly line, whether you're a mining site, whether you're an oil and gas platform, whether you're a semiconductor fab. And on the government side, it's a combination of, again, delivering critical supplies or life-saving supplies to maybe a soldier in the field. And the benefit of that is, especially in a contested environment, you can, because you're doing this using unmanned vehicles, you're not putting other soldiers' lives in harm's way. So
Right.
that's kind of life-saving two ways. And you're using vehicles that, compared to other manned vehicles that are currently used are very inexpensive and very easy to use because they're autonomous and very safe.
Sure. So walk us through the vision of the company, and how do you come up with new products or new weights that you need to support, or new vehicles? Is it mostly customer driven, or are you guys doing some internal research, or a bit of both?
Yeah, so the vision that we have at Volansi is that the world around us is designed based on the limitations of technologies that we've developed. And so what we mean by that is the fact that we have to build so many roads and tunnels and highways and bridges and all this ground infrastructure is that at mass we're really limited to ground transportation solutions. And that's what we talked about, right? Enterprise customers or even consumers. And our mission is to transform the world around the technologies that we're developing, namely VTOL and autonomy, or vertical takeoff and landing and autonomy. And as a result, democratize access to vertical aerial transportation and mobility. And the key word for us here is really access. So we want to enable access for people with a means, with our technology that allows them to get supplies, parts, and get from one point to the other using this technology that would otherwise not be available to them. And how we think about the product roadmap is that we want to start with the lowest hanging fruit, if you will. So serve the customers that have the highest purchasing power, that have the highest need, and have the highest adoption rate. And then over time, work our ways towards other customer segments and other verticals. And ultimately enable applications such as mobility. That means that you could transport passengers from one point to the other. But we're taking a very pragmatic approach to getting there.
Got you. Okay, interesting. So when you say passengers, like, I guess, like, what does that really mean down the road? Like, would you transport me to like an appointment or something? Or is it like kind of like an Uber type thing? Or walk us through that.
Yeah, I think it's really the vision that we share is that 20 years from now, the way you think about transportation ecosystems in general is going to be very, very different. So ground-based transportation is going to be for really cargo or supplies or anything that has a high frequency, has a very high payload, and is very predictable and is just going on a fixed route. So for example, imagine you're transporting cement from Tracy, California here to the Bay Area or to San Francisco. Okay. So in that case, it would make sense to build a railway or a hyperloop or have autonomous trucks going back and forth. But for any type of transportation where you have a level of customization, where it's more infrequent or less predictable, and where you have variable payloads, for example, people commuting to work, or you going to your dentist appointment, as you said, or anything of that nature, aerial transportation is going to become more and more commonplace, and especially with the advent of VTOL technology, which means that the limitations on infrastructure are lifted, and autonomy, which means that limitations on accessibility for different people are lifted. You're going to see that become more and more frequent. And whether it's Uber-like or not, that's really based on the business model. I think it's going to be really a service that people use. I don't think people will be owning their own aerial vehicles necessarily, but that's more of a business model question. But from a technology perspective, I think it's going to be a future where you have a lot of air traffic for customized, less frequent kind of trips and legs, and you will have a lot of ground traffic for more predictable, less customized type of goods and applications.
Sure. No, that makes sense. And I think, like, if you've read any kind of news over the last few years, there's a bunch of companies working on like package delivery through some sort of drone, like Amazon, or like even food delivery, where they just kind of drop it off at your house, right? And it kind of goes away. And I could see that in the future, and it would make sense if, it could transport just like me to an appointment or something. I think that's actually really cool. And I agree with you. I think majority of people probably won't own one. but what is the rough range of owning something like this personally? Is it more affordable? Obviously, it's more probably affordable at this point for a company, but as costs come down, like, do you think it'll be affordable at some point for somebody in the general public?
Absolutely. I think the question, as I said, is from a business model perspective, is not necessarily whether it's going to be affordable or not for you to own it. It's going to be a question of whether it's necessary or not for you to own it. So if this becomes ubiquitous and you can have access to an aerial lift, if you will, anywhere, anytime, then there's really no point of owning a vehicle that does that. But
sure,
that's kind of, I think, the trend you also see in the autonomous ground vehicle space, right? So the question is, do you really need to own a car in the future, or are you always going to be able to be shuttled from one point to the other if you have access to these fleets of vehicles providing the service to you? So I think the similar argument exists there. But personally, I don't think autonomous ground vehicles are going to be necessarily the game changer for us. It's going to be autonomous aerial vehicles, and that's it. That's what the future that I'm excited about.
Interesting. So I'm curious. Obviously, you guys, there's a ton of technology and innovation that has to go into actually engineering this. How do you guys stay current and make sure that you are using kind of the thinnest, lightest, cheapest, strongest materials, and still kind of making sure that you can stay within your company vision and actually execute on this stuff? Because that's got to be extremely challenging.
Yeah, we're a very pragmatic company, as in we don't have dogma around a certain technology. So we, as I mentioned before, really want to solve our customers' problems with whatever technology that we can get our hands on or we're developing internally. We're lucky to have an amazing group of engineers and operators inside the company, and we're staying current on the latest trends, whether it's in the hardware side, manufacturing the vehicles, or on the software side to build autonomy and automation onto the platforms. And all of the technology serves the customer. So whatever technology makes sense to make sure that we serve the customer best, that's the technology that we're adopting. And yes, the industry as a whole is it's really at its infancy in a sense, because a lot of these technologies, especially for larger vehicles, are just being developed, whether it's on the propulsion side for battery technology or motors, electric motors, or on developing airframes from carbon fiber and other composite materials, and doing that at mass. Because again, as I said, if we're thinking about a future where you have millions of these vehicles flying, you have to also think about technologies that allow us to manufacture 1 million air vehicles, and that's not necessarily the case in the air vehicle industry or in the aerospace industry. So I think there's going to be a lot of technology development required in being able to do mass manufacturing of these vehicles.
Sure. And then you touched on something on the software side. How do you guys handle security and privacy? Because you're going through a bunch of geographic regions. It depends on whether it's satellite or radio or SIM or a bunch of different stuff. Walk us through how you guys handle some of that on the software side.
Yeah, I mean, by default, we don't have a camera on the vehicle monitoring or taking pictures. So it's not like a camera drone, like a DJI that you would buy for using for imaging purposes. These are designed to deliver cargo from one point to the other. And then we have some sensors on board for navigation and, as I said, communication with the vehicle, but they're not. They shouldn't create any privacy issues. I think the more interesting problem for us is how to make sure that they're secure and no one else can, take over. So there's cybersecurity issues that we are more concerned with. Less privacy, as in we're not taking pictures of people's properties as we're flying over them.
Sure. No, that makes a lot of sense. And yeah, I guess you're right. It's more of like getting a third party to take over control than. Yeah, that's what I always found interesting with like some of the drone stuff. People get so freaked out about drones, but it's like, well, a lot, like in your case, you're not even taking photos, so it doesn't even really matter. And you're doing something that's trying to help somebody or get something to somebody. So that makes a lot of sense. I'm curious, do you have any other predictions for the future of the space? Because I think, and you can correct me if I'm wrong, what I've been reading online, at least in the battery space, is it seems like there's going to be potentially a bunch of breakthroughs where we're going to have, lighter batteries that we could potentially go longer distances. Is that true? Or what are some other things that you see that are going to maybe really help you guys and other people leveraging hardware, whether it's for flying or other things, maybe in the battery or other technology space?
Yeah, I think the battery technology we're obviously monitoring the trends that we see in the automotive industry and seeing how far they come. Unfortunately, batteries are still not at the right energy density to make sense for our size of vehicles, especially for trying to go over longer distances. I mean, as I said, we have vehicles that are all electric using current latest and greatest battery technology, but you at most can cover a 50-mile distance with them, which is quite a far distance in most use cases. But it's still not to a point where you could go hundreds of miles on one charge or with one battery pack. The magic number for us in general is going to be about getting to battery energy density of about 400 watt hours per kilogram. And while I think that's been proven at a lab scale, not at a mass scale, and with all the other battery technologies that are coming into play, like solid state batteries and so on and so forth, we're definitely monitoring them, but we're not the earliest adopters of that technology right now. We're just using what's the latest and greatest automotive battery technology. But yeah, if that breakthrough happens, that's going to enable electric VTOL or eVTOL, as it's known in our industry, for longer distances, and that's an exciting future. I think it's still 4 to 5 years away from where we're at today to be able to be used at mass, and especially for electric vehicles. But it's not a impossible thing. It's just a matter of when we get there.
Sure. Can you use solar at all, or is it just doesn't make sense for how it's engineered?
You could. When you're trying to use solar, you have to have a large surface area so that you can have a lot of solar panels capturing the energy and then converting it to the electric energy that you need for your motors. So if we wanted to build a solar aircraft, it would have to have really, really long wingspans or really large surface areas. We currently don't have that, and it doesn't make sense for us. But yeah, solar is a possibility, and there are some vehicles that are solar powered, but they're normally flying at higher altitudes, and they don't do a lot of takeoff and landings. They basically are really large fixed wing platforms with a wingspan of like 100 feet, so that they can cover the solar panels on top of them.
Well, and then it doesn't really, that kind of potentially limits some of your corporate or enterprise type clients, right? They obviously need a lot bigger space, and they may or may not have that, right?
Absolutely, yes. I mean, again, one of our key value propositions to customers is that this is a limited infrastructure type of technology. You don't need to build a runway. You don't need to give us like 100-foot by 100-foot area to operate, right? Because we want to be able to operate in confined areas, because that's where most businesses have the availability. And so the more we can limit the size of the vehicles to be able to operate in these areas and still have the functionality that we need from them, that's what we're optimizing the design for, not necessarily for how we maximize solar or other technologies that might require larger wingspans and different infrastructure for takeoff and landing.
Sure. So can you give people a rough size? I know it's kind of hard to do just through audio, but and I can see photos, and people can go to your website and look at photos, but what's roughly the size that people need, or just how big roughly is the aircraft?
Yeah, as I said, the 10 series aircraft, which is a 10-pound payload capacity aircraft, has a 9-foot wingspan. So that's kind of the amount of space you would need at a minimum to be able to land But normally we recommend about a 15 by 15 or 20 by 20 foot space on the ground for takeoff and landing purposes. And our larger vehicles, the 20 series has about a 15-foot wingspan, and it kind of scales up from there. One of our key design philosophies is to try to scale the same design and starting with the smallest form factor, which was a 10, and going up from there. And that's been proven very helpful. So in a sense that we don't need to go and configure and redesign the aircraft every time we're building a next generation or an aircraft with better payload and range capabilities. We can take the same design and incrementally increase payload and range, and take the learnings from the subscale models or the smaller platforms to the larger platforms. And most importantly, really test and develop all of our autonomy and software on a smaller platform, and then scale it to the larger platforms, which allows us to be much more nimble and develop faster, especially on autonomy and software features.
No, very cool. But we're kind of coming to the end of the show. So how about we close with mentioning where people can get more information about yourself, the company, and any other links you want to mention?
Yeah, absolutely. Our website is volansi.com, and please check it out. If you have any questions, we have a contact form there. And if you're interested in working on this technology or working with us, we're always hiring, and we have a ton of open positions right now on our careers page, both in engineering, operations, business, across the board. So we'd love to have any of your listeners, reach out to us and say we're interested in working with you guys and having a discussion with them.
Very cool. And just to spell the domain, it's volansi.com.
That's correct. Yeah.
Perfect.
By the way, maybe just one thing that your listeners might be interested, because often people ask me is, where does the name come from? Volansi is basically an amalgamation of two Latin words, volans and ultilium. Okay. So it means basically flying and electric energy or battery. So the idea is basically we're saying we're building a flying battery. So that's how the name started, or the name comes from.
Very cool. Well, I really appreciate you taking the time out of your day to be on the show. I look forward to keeping in touch with you, and have a good rest of your day.
Yeah, thanks for having me, and really enjoyed speaking with you today.
Me as well. Have a good rest of your day. We'll talk soon. Okay.
Thanks, you too. Bye.
Welcome to Building the Future, hosted by Kevin Horek. With millions of listeners a month, Building the Future has quickly become one of the fastest rising programs, with a focus on interviewing startups, entrepreneurs, investors, CEOs, and more. The radio and TV show airs in 15 markets across the globe, including Silicon Valley. For full showtimes, past episodes, or to sponsor the show, please visit buildingthefutureshow.com.